Let's say I'm teaching an algebra class and the topic du jour is how to factor. And it's those coefficient of the quadratic, not a one kind of situation. So we're going to either be doing trial and check or the AC method. In such a scenario, I might take the time, in fact, I absolutely will take the time to show every step of factoring every single time. But most of the time, I'm not doing that. Most of the time, I'm teaching something that is higher than that, and it's assumed that we all already know how to factor. And I will absolutely show you how to factor if you say, hey, what was that factoring? But it's usually in a class where factoring is not the goal of the day. Something else pressuring us is the goal of the day. So students have often said, how do you do it in your head so fast when you're teaching a class? And the answer is practice, a lot of practice. But what I'm doing is I'm blending a trial and check and AC method inside my head. Now, I will never teach it this way because I can't get a classroom to do this consistently together. So I'm going to kind of pull back the curtain on what's going on inside my mind when I am factoring in super speed. This is absolutely a do as I say and not as I do. I'm not going to have you blend these methods, but here's what's happening in my head. Here's the trinomial. Let's set up trial and check, but let's also multiply the first and last terms together and kind of play with AC method a little bit. Wonderfully, the coefficient of the quadratic is a prime number, so I know that I only have the option of 2x and x. That's all I got. But when I do the AC method, and this is a hill I will die on, it's not just the first and last coefficients, it's the entire term, because if you're actually doing AC method, it makes it so much easier for Pete's sake. Anyway, so first and last terms together, multiply them, you get a 6x squared. There are only two factor pairs that multiply to give us 6x squared. That's 2x and 3x. And the other pair is x and 6x. X and 6x is the pair that would multiply to give me that 7x in the middle. So that's the one that we're going with. After this, we're going to abandon the AC method. That 2x has to be a factor of one of these two things, and it must be the 6x. So therefore, the things I need to put in the outer spot, since I already have a 2x, its mate would be a 3. I know I need to put a 3 in that other spot because I need to build a 6x out of that. Which means that the inner terms have to multiply to give me x, and there's only one possibility for that. So now we have our factors, make sure it makes sense with the original trinomial. Here's another trinomial. Now I'm not going to fill in my trial and check first terms yet because I have too many possibilities. So start your AC method. And by that I mean multiply the first and last terms together, get a positive 24x squared, and I need two things that multiply to give me a positive 24, so therefore they must be the same sign, but they need to add to give me a negative 11, so they must both be negative, and the numbers that would work that are the factors of 24 would be 8 and 3, so therefore it must be negative 8x minus 3x, and that would be what you would use to replace your negative 11x if you were doing the AC method, but we're going to stop doing it here. Side note, if you are actually going to do the AC method, and if I'm actually teaching you in an algebra class, I would make you make the whole list right here, because this is what we do when we're new. So the factors of 24, I'm going to start counting. So that would be 1 and its pair 24, 2 and its pair 12, 3 and its pair 8, 4 and its pair 6. Each one gets an x. We need to add to a negative 11. They each get negatives, that kind of thing. You see how we make a very orderly list whenever we're learning how to do it? I would still expect this if you are learning how to do the AC method. But learning the AC method is not what we're doing today. Now, that 12, I need to split it in a way that gives me one of those two factors. So I'm going to start with the 3 because that's a prime number and it's easier to work with. Well, if I have a 3 and I am dealing with factors of 12 in the beginning spots or 2 in the end spots, I know that that 3 can't go in one of those end spots because 2 does not have a factor of 3, but 12 does. So I'm going to put it in one of those beginning spots. So the rest of the stuff that I have to multiply by 3x to get a 12x squared would be a 4x, which means that goes in the first spot. And then if I'm trying to build out a negative 8x, then the thing that has to go in the other outer spot would be a negative 2. Make sure it makes sense with the original trinomial. Here's another trinomial. Can you predict what I'm about to say? Neither 10 nor 6 is a prime number, and also they have a common factor of 2, so I can't start building out my trial and check yet. So I'm going to use my sort of AC method-ish stuff and multiply the first and last terms together, so that negative 60x squared comes from multiplying the first and last terms together. And then the factors are going to have different signs, and that means they need to subtract to give me the middle. And the factors that subtract to give me 11 would be a negative 15 plus 4. I should say integers that add 2. Blah, blah, blah. Again, If you were learning how to do the AC method, I would expect you to make this list. See how orderly it is? See how the left side is 1, 2, 3, 4, 5, 6, a bunch of the factors, and then the pair is matched up with it on the other side, the thing that would multiply to give me a 60 with that thing? But once you're kind of savvy with this, you know that there are some things you don't need to try. Like, for example, anything that has a common factor, like the 2 and the 30, or the 6 and the 10, we can't try that because we know that that would generate some other sort of common factor, and there's no GCF in the original trinomial, so let's get rid of those. Another thing is that if I need to subtract numbers and get an odd number, then they must be made up of one odd and one even. So I couldn't have two evens, and I can't have two odds. Then it just becomes a matter of whittling it down to the ones that subtract to give me an 11. It's this pair. But, you know, that's when you're first learning AC method. Not particularly concerned right now. I'm going to split up that 10 as a 5 and a 2. And if I have a 5x as the beginning of my outer, and one of them needs to multiply to give me one of those two things we've already picked out, well, that means that the 5x has to multiply times something to give me the negative 15. That means my other number that's going to be part of the outer part of FOIL is going to be a negative 3. Get it from there? And if I need to put a negative 3 in that last spot so it catches that positive 5x and multiplies to give me the negative 15x, that means that the rest of it needs to multiply to give me that 4x. So the 2x times something needs to give me that 4x, and this would be plus 2. Does it make sense with your original trinomial? Here's another trinomial. See how the first and last have a common factor, but it is not a common factor for the whole trinomial? That means that I need to start by breaking up my AC method big factor first. Here's how I'm going to get that positive 17x. I'm not bothering with a 6 and a 3 because those are common factors we've already discussed. We can't use those. You can think of this as the inner stuff needs to multiply together to get 1, so it can't have any other kind of factors, coefficients, any fun stuff in it. But I would rather think of this as, in order to build out that 18, it's going to need like all the xp here. So I'm going to put that 6x and 3x on the outers so that they can multiply together to give me that big old 18. Which means that the innards need to multiply to give me a negative x. Now here's the work to one of those problems using the AC method. This is all of the work that I would expect of you if the goal is to teach you how to use the AC method. But what often happens is that in class, if the topic of that day is not how to factor, but we're just using factoring to do something else, then I might write down the factored form as fast as I can write. And so when students say, how are you doing it in your head that fast, as fast as you can write? This is what's going on in my head. Well, not this is AC method, but the rest of the video. That is what is going on in my head. So that is happening in just seconds. You know, as fast as I can write it down, then I can get its factored form. But there are too many moving parts to be able to teach that effectively in class. So if I'm trying to teach you how to factor, I will show you all of the work. If I'm not trying to teach you how to factor, I'm probably just going to be doing this in my head and then moving on to the next thing. If you ask me, hey, can you show me how to factor that? Absolutely, every single time. I will probably say, would you like me to use trial and check, or would you like me to use AC method? Because whatever works in your head is what we're going to do. Whoever asks the question wins the game. But this is really very much a do as I say and not as I do. And what I tell you is that I need you to get really, really good at trial and check, or I need you to get really, really good at AC method. What I'm doing is I'm blending them together. Not on the screen, but what I'm doing in my head is I'm blending them together. But that is something that comes with a lot of practice. So this is what's happening. I don't expect you to do that, and if you are learning how to factor, I expect you not to do what I have done for most of this video. If you're a calculus student, maybe we can try this, as long as you are so good at factoring that you get it right every single time.